Bigasha Bigara. Have you had your dram of Irish whiskey today, boys?
As you noticed tonight, we invited you in. I had the pleasure of attending a meeting where it got bombed, and it was not pleasant.
Yeah.
So now I put up some ways to trying to stop bombs. That's why we've changed our method of getting in.
Yeah.
As the waiting room.
Go ahead. You were going to say, Randy?
Said you've added the waiting room, right?
Yeah.
Okay, do your announcement.
Okay, welcome to the Royal Astronomical Society St. John Centre. Tonight is a beautiful night. I thought there'd be no people coming because the day was such a beautiful day. Then it's been the first day since we've had a nice clear sky. I figured we'd have less people showing up. I'll get Randy to take over because he's got the list in front of him.
Okay. After we have our welcome introduction, we have speakers, Chris and Phil, doing remote sensing on Mars. Shaziana is going to do a brief outline of an outreach event called Yuri's Night, Yuri Gagarin, observations and photos, and Nikolai will do his Sky this month. And then we'll have any other member input after that.
Okay. I'd like our meeting tonight, our speakers are a combination of Chris and Phil. Chris Stevenson.
Time to unmute.
Yes.
We're just going to launch right into chat. We're just going to launch right into it.
You have to make us co-hosts or something of that nature in order for us.
No, you should be able to share.
Yeah, I can share.
Okay,
Are we ready?
No worries then.
Are we ready?
Yeah, go for it.
All right, here we go. Okay, so the idea here is Phil and I had a phone call last night to try and decide what it is we're going to do because neither one of us had prepared a single slide at that point. So this is thrown to maybe Phil had lots of slides put together and he was just pulling my leg, but I didn't have any.
No.
So I've got more than 5, but I've got less than 20, and I can fly through them very quickly. This is basically just going to be a pretty picture, quick summary of publicly available information on 2 of 3 Mars missions that are currently in the public infosphere, I guess. And Phil, you're going to do number 3. You're going to take over Perseverance, and I think you have some goodies for us and so on and so forth. Actually, I have no idea what you have for us, so we'll see.
Me neither.
Oh, well, there you go.
Carry on.
And I apologize, there is a definite lack of green in this talk.
That's all right.
I figure Mars, you can stare at Mars for a while, close your eyes, and you see a green after image, then that'll do, right? So
there's little green men too.
Yes, little green men. That's right. So these 3 missions are the United Arab Emirates Al Amal or Hope spacecraft, and that's an orbiter, and first ever from them. A mission from China, Tianwen-1. I don't know what 1 is in China. Chinese, anyway. Mandarin, I should know that. Which roughly translates to questions to heaven or questioning heaven for divine truth or whatever. That's an ambitious mission with an orbiter, a lander, and a rover. And number 3 of 3, which happened a week later, so it decided to stay in the sidelines until the hubbub calmed down from the first 2, and then it stole the stage, would be NASA's Perseverance orbiter, of course. Perseverance rover. I'm not going to touch that, so that's the only time I'm mentioning it in this talk, right there. So Phil will do that afterwards. I'm going to start with a brief comment on why these things all happen in bunches. Well, they do now. Lots of people are launching missions everywhere. Why 3 missions all at almost the same time? Why not more spread out? Well, the sun is awfully big. It's very massive. Life around the sun is very go with the flow as it is. It's too massive to argue with, so you're compelled in any trip around the sun, unless you want to burn ridiculous amounts of propellant to go in as straight a line as you can, and you can't carry enough propellant with you to do that. So paths around the sun are all going to be orbits. Everything orbiting the sun is an orbit. It's going to be an ellipse with the sun at one focus of the ellipse. And in order to get from the Earth's orbit, and the Earth is on Earth's orbit, to Mars, which is of course is on Mars' orbit, the path you're going to follow is an elliptical orbit. Sun is at one focus, and this ellipse is going to join the two. And you're going to time it just right, such that if you left Earth at a certain time, your spacecraft would show up at Mars's orbit when Mars does. That's important, because otherwise there'll just be empty space there waiting for you. And you'll drop into orbit around Mars and do whatever you want to do. And if you want to go to the surface, you'll slow down a bit more so you fall to the surface. Slide down the gravity well onto Mars' surface. So the last opportunity for this, I forget how often, you can go through the roster of missions down through history to figure out when these windows occur. 2014, I think, was the last one. No. Yes, anyway. Sorry, I'm being distracted from the kitchen. The animation here is actually the United Arab Emirates spacecraft flying to Mars from Earth's orbit. It launched in July of 2020. They all launched in July of 2020 because that was the launch window for all three missions. So all three missions made it. This is only one slide on this concept. Getting to Mars has historically been difficult. Very roughly, the failure rate is maybe half in the 60s and 70s, and it was starting to get better and better. But a big oops, a fairly recent one, was on September 23rd, 1999, where after 7-ish months flying to Mars, everything looking good, NASA's Mars Climate Orbiter burned up on re-entry. And and the error was traced down to a confusion between metric and imperial units in the navigational code. Oops, big oops. So yeah, we don't no longer make errors like that, we think, and maybe all three missions getting there this time proves that we're getting better at it. United Arab Emirates and China have now joined the party. The party at Mars, I believe India has also been there, England, Britain has also been there, and of course Russia and the United States, all the way back to the 60s. And I couldn't resist, because when I was a kid, I liked this sci-fi television program. Space 1999, some of the older people out here would remember this television show, and there's this fanciful explosion happening on the nuclear dump on the far side of the moon, and it's blasted the moon out of Earth's orbit, which is physically impossible, but it happened on September 13th, 1999, so within 10 days. So maybe the person who made the oops was a Space 1999 fan and didn't know it. So, UAA's hope. The United Arab Emirates does not have its own really well-developed space program, so there's a lot of partnership going on. The space probe was actually assembled in Boulder, Colorado, and launched by Japan at the Tanegashima Space Center in Japan on their H-2A rocket, which is a large rocket. And so here you can see it going to the payload fairing. Here it is launch. The launch was on the 20th of July. Here's the mission logo. And this was the first mission to arrive at Mars on the 9th of February. And everybody over there was fantastically happy, and they celebrated with a light show on the Burj Khalifa, which is the world's tallest building. Let's see if I can get this to play. Well, there are lights dancing all over the tower, and there's music playing, and everyone is very, very happy. I'm sure you can find it. I'm going to go back to the slides. This is taking too long to load. So the space probe itself is fairly simple. It's a gold foil covered box, basically 3-by-ish meter box, covered in foil, loaded with instruments, and a couple of large 900 kilowatt solar panels. It's about the size of a small car, and After its engine burn, it settled into a very elliptical orbit around Mars, which it will roughly circularize over the next little bit into a science orbit. That's about 20,000 by 43,000 kilometers, a period of just over 2 days. And the mission, the science goals for this mission are to study the atmosphere of Mars, and specifically the dynamics, energy dynamics, and what happens when the cosmic rays dissociate water molecules and into hydrogen and oxygen, which leave the atmosphere. And being far away from the surface of Mars helps with this. So you can see the whole planet at once. This is what they say. So the hope is to connect this cosmic ray process and escaping O and H ions with Martian weather, and be able to better predict Martian weather. And of course, with lots of things on the surface, Martian weather is a going concern. The mission is planned to last at least 2 Earth years or 1 Martian year. So we wish them luck. They're there. And one day after it got there, it returned this beautiful photo. And Phil last night commented on, "You have to include this photo." I said, "Don't worry, I'm going to include this photo." It's absolutely lovely. And it's the sort of photo that as telescope users, we gravitate to this, because it's sort of a whole picture. Here you can see the 3 shield volcanoes of Acraeus Mons, Pavonis Mons, and Arsia Mons. Olympus Mons is right at the terminator here. You can see Valles Marineris here just at the limb. There's upper altitude cloud. This is the North Pole. So you can see lots of features all at once here. This is a beautiful, pretty picture of Mars. So hopefully there's lots more from this mission. Half done. The next mission is from China, and this one's very ambitious. Tianwen translates perhaps to Quest for Heavenly Truth, and it actually comes from the long poem written by ancient Chinese poet Ku Huan. This is about 340 to 278 BC. Yes, I got these facts from Wikipedia, and so can you. China has, of course, been doing great guns with unmanned missions. They had a whole series of missions to the moon in the last decade, the Chang'e missions. And one of them was even a sample return mission. And the Chang'e 5, the last one. And they had rovers, I think they had 2 rovers, U2 Rabbit, I think. All very poetic names, it's wonderful. But they've succeeded. And they succeeded again. They also got to Mars. They dropped into orbit. The Tianwen-1 spacecraft is larger than Hope, considerably larger. You can see to scale the people here in the bottom of this photo. I don't know if people can see my cursor flying around here. So this is a large vehicle. The lander rover pair are in this aeroshell mounted on top. And they have a more developed space program, so they actually have their own launch facilities. The Long March 5 rocket is their biggest. They use that to launch this thing on the 23rd, should be, of July. And on the way, they actually put cameras everywhere on this thing. One of the cameras was supposed to pop off and take a picture of the spacecraft from not on the spacecraft, a selfie as it were. And here it is, taken on the 20th of September, when the spacecraft was in deep space between Earth and Mars. That's pretty cool, I think. It's always nice to see where you're going. They didn't have to do this, but this is pure PR. I guess you could check to make sure the solar panels are still there or something, I don't know. So Tianwen 1 took this image of Mars when it was approaching in early February. It actually got to February on the 10th of the month, 1 day after Hope. And it was followed. China was pretty secretive about. They never had live coverage of dropping into orbit, but there were amateurs that were monitoring the transmissions from the spacecraft in real time, and they could see the Doppler shift occur when its engines turned on. So they knew the moment when the Tianwen-1 spacecraft was braking to fall into Mars orbit. A week or so later, China released video taken from the spacecraft of this happening. from engineering cameras on the spacecraft. And let me guess, this is not going to load either. You can find all this stuff on Spaceflight now. And in fact, if you just Google Tianwen-1 video, you'll probably find it on the internet at large. Ah, this is too bad. I was wanting to play this video. I don't know why they're not loading. Rats. On with the show. So again, like Hope, the initial orbit was very elliptical, and then they circularize it a little bit in successive passes with the successive motor burns to draw to produce a science orbit. In the Tianwen-1's case, that science orbit is somewhat elliptical, well, quite actually, but 12,000 kilometers periapsis from Mars, and as little as 265 kilometers from the surface at apophysis, and closest 265 kilometers. So the orbiter has a large retinue of instruments. I am not going to go through these at all in any detail, or any detail at all. In fact, only to mention them. It's got a bunch of cameras, medium and high resolution cameras. It has a space-based subsurface exploration radar, which I thought was curious. The main science goals for this mission are geology, and so it has a mineralogy spectrometer on board the orbiter, magnetometer, ion and neutral particle analyzer, and energetic particle analyzer. So that's only on the orbiter. The lander, once they get into their science orbit and check things out and so on, the lander should descend to the surface in May or June, and hopefully land in Utopia Planitia, and I don't know whether they planned it this way or not, but somewhat near Viking 2 of the 1970s. The lander, actually the rover has all the instrumentation. The lander is basically, I think, just the carrying platform for the rover. The rover has a multispectral camera, a terrain camera, I guess it's a wider angle thing. It also has subsurface exploration radar, so up close. This would be the first time we've ever had subsurface radar on Mars. I understand, I'm not an expert. Surface composition detector, magnetic field detector, meteorology monitor, so weather station. So that's it. So we'll be looking forward to seeing more pictures from both missions, and especially for the landing of this rover and yet another rover on the surface. I'm going to pass it over to Phil, if Phil is ready. There's a list of references here, by the way, in the recorded version of this talk. You can consult the references. A lot of it came from Wikipedia, space.com, bbc.com, Spaceflight Now, and there's also another one I did check, Unmanned Spaceflight, all one word, .com, has information, exhaustive amounts of information on every mission that's ever been, so check that out. I'm going to unshare my screen at this point. And Phil, you can take over.
Yeah, thanks, Chris. Yeah, that was really cool. I have some things to say about Perseverance, and I don't have any picture of its launch. I didn't look at that, so you got launches and other things of the other two spacecraft, but I'm just going to basically drop right into the current activities of Perseverance and a little bit of background for that. Let's see if I can share my screen. Haha. And okay, it was just very slow coming. Okay.
There we go.
Slow to load. Okay, yeah. No, I'm on an older laptop here, so okay, that's par for the course, I guess. All right then. So I'm gonna start this and see where we are with it. Here, how's that look?
Good.
Okay. Yeah, so this is obviously, and what's nice about this is it shows albedo as well, so it's actually a pretty good crossover map with what we have seen from the all the members telescopically, even you sort of get a sense of, you know, there's Ceritus over here. There's the Tharsis area over here. Sometimes with telescopically, we get clouds associated with that. So these are the landing sites that up until now, including the most recent landing site at Perseverance, which is somewhat right of center in this view. So this map is kind of just an overview composite map of Mars showing the largest impact basins. Oops, let's go back. The Hellas Basin is down here, biggest impact basin on Mars anyway, a very deep one. Chris showed a picture from the HOPE orbiter showing the Tharsis volcanoes. I don't know if you can see my pointer or not, but over on the left of center side of here, the 3 pimples that are on the map here in a row, that's the 3 Tharsis major volcanoes, and then Olympus Mons is just to the northwest of them. And Valles Marineris here is the big valley, the big gash running right along the equator here, just to the left of center. So these are the landing sites of Martian landers over the years from 1976 with the 2 Vikings. There's Viking 2 up in Utopia and Viking 1. And Chris, you were saying Chinese landers to go down somewhere just south of Viking, I suppose. Curiosity is in Gale Crater sitting over here. Basically along, we see this telescopically as this boundary here that roughly is in accord with the dichotomy boundary between the southern highlands in Mars, which are very old, and the northern lowlands, which are kind of filled in with lots of sediment and perhaps somewhat younger. So the Curiosity rover is sort of booting around there, trying to climb Mount Sharp. The InSight lander, which is a stationary lander with a seismometer in it, is just north of Curiosity. And the new landing on Mars right now, until the Chinese do it, is Perseverance, which landed there last month in the northwest corner of Isidis Basin in suddenly on Jezero Crater. Yeah. So I'm going to talk here mainly about operations that are now happening on the ground with Perseverance, and then we can open this up to just general discussion. I'm taking part in a meeting this week. I have nothing to do with any of these operations. I'm just interested, as we all are. But I'm taking part in a meeting this week, which is a scientific meeting called the Lunar and Planetary Science Conference. It always happens this time of year in March in Houston, and usually I'm down in Houston in that area. Last year, the meeting was canceled because that was right on top of when the pandemic hit. This year, they made it a virtual meeting, so we're all sitting at home, basically, or in our offices, and taking in talks and so on. And happily for us, yesterday and today, especially yesterday, was a whole suite of talks 1 month after the landing of the operations of the Mars 2020 rover Perseverance. So that's what I did, is I just screen captured pictures from their talks, all of which are publicly available anyway, but they've annotated things in the pictures. So it's not necessarily entirely what's publicly available. Nothing terribly earth-shaking about this, as it were, but just nevertheless, there's some neat things in here. So I'll go through some of these fairly quickly, and then we can have a chat about it. So this is from a talk by Chris Hurd and others. He was the speaker. Chris Hurd is at the University of Alberta. So there's some other people, including Canadians, taking prominent positions in the mission profile for this lander, which is kind of neat. Chris Hurd is particularly interested. We should ask him actually to give a talk with the center at some point. He'd be a neat speaker. Chris Hurd is particularly interested in setting the foundations for sample return. You've probably heard that this rover, certainly a lot of the public notice about the rover, is that it's going around and selecting samples for sample return. This rover itself does not have the capability to return samples, but they're collecting samples and they're going to cache them. And as I learned at the meeting here, there are the intent anyway is that there will be 2 sample caches, and a future mission, maybe 8 years from now or so, 6, 7, 8 years from now or later, would go to this area with the specific purpose of recovering these samples and then going back to Earth with the samples so that we can examine what Perseverance finds. in laboratories back on Earth, which would be fantastic. So this is the setting here. You saw from the previous map where Perseverance was sitting in the northwest corner of Isidis. Here's the Isidis impact basin here. Jezero crater is here on the corner of that. We're right on the border, same as largely where Curiosity is, further off to the east of here. We're basically at the zone where we're going from the southern highlands, which are high. They're higher elevation, and they tend to be older. So water, if it was present and when it was present, it tended to drain off of the highlands and go into the northern lowlands and fill these basins. So we're sort of at this nice nexus of lots of fluvial activity, and that was the real driver for this being a landing site chosen for Perseverance. So you can see Jezero crater here on the right, and entering, you can see a kind of windy channel called Lower Inlet Valley, winding in and coming into Jezero crater there. What made this landing area extremely interesting is there's abundant evidence right from orbit that you can see there's this big delta built out of there. So a lot of sediment came charging through here, was dumped into the crater, and then there's an outlet channel off on the upper right side, leaving the screen here. So this was, at some point in its history, a fluvial system where a lot of material was brought in by water and dumped here, and then the outlet channel on the other side. So the big driver for all of these Mars missions is to try to figure out what the possible environment on Mars might have been on the surface in the past, and could there have been life? Was it habitable? So this is basically one of the major goals of this mission, is to go in and investigate it geologically to figure out if there's evidence for either organic molecules that might be related to life having present, or what are the other mineralogical indicators that we had conditions that were conducive to having life. So this is just a nice general image of Jezero crater with no labels on it, but over just left of center here, you can see the inlet channel here and the delta, and the rover has come down just off the tip of the delta there. This is from another talk by Williford and others, and where they actually are looking for habitable environment types or niches in and around Jezero. So here are possible basically areas that the rover could, or environments that the rover could encounter while it is starting off somewhere down in the plains down here and working its way up into the highlands up off to the left. So these are numbered fracture systems. So you could have water sitting within fracture systems at some point in the crater's history as a hydrothermal system. When Jezero was an active first formed crater, if there was water around, it might have been a hydrothermal system. When this thing filled with water, when we had all this water spilling out from the highlands into the basin, there's a lake basin, so there's a possibility that you'd have like a lake that would fill with fine sediments, and that's a possible place for life, a different one. Then there's the river itself. Number 3 here, river sands might record something. A high target is the area that would be the lake margin or an ancient shoreline, where there might have been a lot of interactivity between the lake surface and the atmosphere, and input of more materials. So that might have been a good location where we could have the energy drivers for life to be present. And then climbing up into the highlands, there's the area that's the crater rim, which is thought to perhaps be a host. When the crater formed, you'd have hydrothermal systems that would be associated with groundwater getting in, getting heated up by the resident heat from the impact, and then coming out in around the crater rim area. So that's possibly a source of hydrothermal related life early in the crater's history. And then finally, getting off into the highlands, going back further in Mars's history. Some of the oldest rocks on Mars are sitting off in the southwest corner in the lower left here. And back in the earlier Mars history, it was thought to be perhaps warmer and wetter, and we might have an aquifer kind of system preserved in rocks out there. So anyway, I'm talking too much, but this is sort of the overall goal of the mission. Chris has this map, he and co-authors, where they've basically outlined different units. I'm not going to spend a lot of time walking through all the things here, but basically the big circle here, the black circle, encompasses the intended landing area, and they actually landed out here in the plains. The intended landed area of the initial mission is sort of out here, and then the extended mission is going to be inland, going up near Vallis into the highlands up here. So this is sort of a broad overview looking at the possible terrain types that they're going to encounter along the way. So the in the notional landing sites, so some of these slides are basically what they were thinking before the landing, and they were intending, if possible, to land fairly close to the tongue of the delta. All this blue unit here is the outflow delta unit. And then there's outliers of delta units sitting here and there out in the basin. They were intending to land somewhere in here, but the landing ellipse is larger than that. And the actual landing site was, it automatically steered the spacecraft to the lander to come down out here. Safe landing, but now they're out here, and this gray terrain here, this fractured, rough, mafic floor, quote unquote, unit, is considered by the engineers to be too difficult to traverse. So they now have to basically decide in the next little while if they're going to drive clockwise or around this, meaning going around this way, or counterclockwise around this way to get into what their mission plan, to go up the valley here and go on up and into the interior. So the initial mission is in here for the next, Martian year. And then beyond the first Martian year, the idea is to be further inland after that. Okay, just very quickly, the kinds of samples that they figure they might take and cache in the notional initial depot would be a bunch of vials that they fill with different materials, hydrated silica from a hydrothermal deposit, some of the crater rim material, some of the crater floor material. Even though they can't drive over it, they would like to sample it. Some of the mudstones from the delta and some of the areas from the margin of the delta curvilinear contact. So that would be the first cache, and that's sort of the goal. The initial goal of the mission is to get something cached. So whatever happens to the rover after the first year or so, at least there's samples that have been cached somewhere that a future mission can come and get. And they have these other ones, duplicate samples of these first ones that they would take. They would take duplicate samples, keep them with the rover, and that provides a kind of redundancy for later so that they create a second cache. So just in case for some reason the first cache is never visited and they end up sending a spacecraft to the second cache, they have representative samples from the first part of the mission and then also samples from the extended mission. So a lot of careful thinking is going into what kind of samples are going to be taken for what reason and what to do with them, and to make it as simple as possible to pick them up later. So the extended mission scenario, after one whole Martian year from the start point, that's their notional start point. Remember, they're actually sitting out here. So this is going to, maybe change where they get to and how much time it takes to do it. But anyway, in any case, the extended mission goes way, way, way away from the landing site and goes well into the interior here and visits some of the oldest rocks on Mars. So this whole traverse maybe covers something like nearly 1.5 billion years of Martian history, probably. And the idea, one of the goals of this is to bring back sample, for one thing, quite apart from looking for signs of life. The other thing is to really just get a good handle, having any return samples at all of known units on Mars. You can start to put in the crater counting record for the Martian surface. You can figure out then what the absolute ages are and hang that whole crater counting chronology of the surface of Mars. You can hang it on an actual set of age dates from different units. So this mission, going through such varied terrains, younger basalts and much older terrains, is really useful in that it could actually do a lot to, just in one mission with return samples, could do a lot to provide a framework for getting real ages for the events on Mars, which would be really cool. Okay, so the rest of the talk, I'm just going to fly through some images. I don't have any movies keyed up. Maybe, Chris, you could find a movie to play after I'm finished with this. That would be cool. There are very nice movies of the landings out there. These are still images. This fellow sitting over on the right, Justin Mackey, he's one of the speakers from yesterday, and he's the camera guy on the rover. He's the guy in charge of all of these cameras that we see laid out for a nice family portrait, as he called it, in front of them. And they're all basically rover descent camera, the descent stage camera, the rover uplook camera, and these three cameras over here, PUC, they're parachute uplook cameras from the descent stage. So we'll see what they do in a moment. You've all seen, I suppose, if you've looked at it, you've seen videos of this already, but there are some nice stills here. And he had it nicely laid out here of what the cameras do. The parachute uplook cameras are from the descent stage. They're looking up to see how the parachute deploys. The descent stage downlook camera is looking at the ground as it comes down, looking at the descent of the rover to the ground. And in the background, he had this video playing continuously in the background of his talk. And then the rover uplook camera is, once the rover detaches, it looks back up at the descent stage while it's hovering there before it takes off and away. And then the rover downlook camera is the rover approaching the surface and eventually on the surface. So there's a bunch of things. There's a microphone too, actually, on the rover as well. So this is looking up at the parachute deploying in the Martian stratosphere. And it's a drone shoot. It's basically, it deploys, and in order to slow the spacecraft down as it comes in, or else it's just going to go splat in the ground. So these are images from one of the cameras showing the chute deploying. Very nice view of it there, fully deployed. This is a different camera view. Here the sun angle is over on the bottom right. Here the sun angle is over on the left of the image. So they had three cameras, and this is the chute deploying from the other camera. Some of you may have, if you've looked at this online, you might be wondering about this interesting design of the chute. One of the things from engineering point of view is they want to figure out how the chute operates. It's a handmade parachute, very carefully made. And they want to be able to track with the cameras how it behaved during landing to improve on its performance in the future. And so you have to know what the orientation of the chute is in different parts of it. So it's got this very unique geometrical pattern, which people figured out in about half a day. Once this was all posted online, they figured out it was in binary code in rings cutting outwards from the center, and it spells out a word: dare mighty things. So that's really cool. And then the outermost ring of the chute outside of the airlet here is the Latin long coordinates of the Jet Propulsion Laboratory in California. So I thought that was pretty cool. They're having a lot of fun with this. So this is the descent camera. And as they're approaching the surface, the sky crane basically has engines thrusters that are keeping it aloft, and it makes for 4 blast zones, basically bracketing the area where the rover is actually going to descend. So you can see the dust getting kicked up on the ground here, and eventually it kind of blanks out. And then the rover, looking back up at the descent stage, is looking back up. It's hoisted on these 3 taut cables here are holding the rover, and then this is an information line. This is the communication link hanging there between the 2 of them. And that's the opposite view, looking down at the rover as it's being lowered to the ground. And this is also a descent view from further back up with a kind of a fisheye lens of the area. So you can see the delta here of Jezero, and then the plane where they're actually going to come down is around here, which is a pretty neat view. So once on the ground, they still have dust covers on the HAZ cams. And so these were the very first images that those of us who were looking at that rate when it was transmitted, these were the first views that came back to confirm that it was on the ground. Within 40 seconds of touchdown, they took these images and sent them. Kind of fuzzy looking images because they still have the dust covers on the cameras. One of the things that Justin Mackey was really happy to report was the rear HAZ cam. They were hoping that they would see the descent stage crash, and they did. You know, that part that detached and flew away, it crashed some distance away, and they can see the crash plume over there 40 seconds after the landing. It's sitting on the horizon over there, which is pretty neat. Then when the dust covers are taken away, then they have really nice dust-free views of the surface. So that I'm just going to walk through these images fairly fast. And they can do color calibrations and color corrections to get what Mars's surface would really look like if you were, in your SUV or car and you had a backup camera. This is probably what you'd see too if you were on Mars. It's pretty cool. And they're checking out the instrument deck, before unfurling things, just to check out to make sure things are where they should be. Chris's comment on looking to make sure the solar panels are still there with the Chinese spacecraft on the way, that there's some seriousness to that. They actually do want to have independent confirmation that these things are still where they're supposed to be. There's some nice images of the horizon here. And some of the blast area around where the lander came down. And this is the first really well rendered full color image from the surface. That is looking back at, this is looking back at the landing site, and Mackie's comment on that is yes, the rover actually did literally drop out of the sky. That's its first marks on the ground, the 6 wheels down on the ground, and then it drove away and took a look back. And there's on the right and left of that area are the blast areas where the descent unit basically blasted away the dust. So this is modified Martian surface. When you blow the dust off, that's what it looks like, and maybe bake it a bit. So this is again a nice look, pretty much at what the surface would look like if you were standing on the surface of Mars. It kind of looked kind of pebbly like this at that location. It's pretty neat. One of the neat things they're doing with the cameras is that they're able, because they have stereo view with the cameras, both the HazCams and the ones up in the mast, is that they can create a 3-dimensional grid and overlay it, helping for planning traverses with the rover. So that's one of the things that's kind of done with the mission, almost not quite in real time, but almost in real time for planning purposes. You can figure out what the landscape is doing just from integrating the camera views and getting a 3D, basically digital model of the terrain immediately surrounding the rover. Some of the things immediately from the landing here is the blast areas are indicated here, and so we cleared off the immediate dust, and you're getting a sort of look at the longer lived surface that's there. And then some of these rocks here, it's hard to tell without brushing dust off of them what their real color is, but the guess is probably dust coated, and a lot of the rocks in the area are like that. And then after driving away 38 meters away, that's the landing area there, and now we've driven away. So there he is, very happy guy. Jim Bell and others talked about some of the first work of the Mastcam Z, as they call it. We would call it Mastcam Z, but it's an American instrument, so we'll go with Mastcam Z, as they call it, which is their high-quality zoom camera sitting up on the mast. And it's able to get, as the name suggests, the high zoomed-in images and high resolution images of targets of interest on the surface. And that's the one they're doing a lot of these really nice panoramic views with. So this was their first set of test images to try to test to make sure that they had the focus and the resolution that the instrument is supposed to have. And we're getting pretty good look at the surface. This is from a camera sitting up a couple of meters above the surface, and they're getting, down to 1 millimeter size grains that they can pick off looking down at the ground, so that's pretty neat. This is a portion of one of those panoramas, including the rover in the foreground, and a portion of the image. You can take a portion of the image sitting out here. They call this one Harbor Seal for obvious reasons. This little ventifracted outcrop out here, and you blow up that portion of the image, and you have plenty of detail in there to play with. So it's really, really nice images. They also indicate here that you can get them directly. These images, these panoramas and so on are publicly available, and it's at this photojournal JPL site. You could probably find it fairly handily. Here's a look with the panorama from the camera looking back at the landing area and seeing that some of these boulders are particularly scoured out and maybe a little toasty. So they're going to figure out whether these have actually been toasted or whether that's their real color. Some of the interesting things around the landing site is some of the rocks look very unusual, have all these pits and holes in them that have some orientation in them, ventifacted, meaning it's been perhaps scooped out by the wind. That occurs in some desert environments on Earth where we have either vesicular basalt, so like bubbly basalt rocks is possible, or it could be, if this is supposed to be an area that has a lot of carbonate in it, so maybe these are carbonate rocks and with some dissolution pits in there perhaps, and it's preferentially getting taken out by the wind. There's a lot unknown about that yet, lots to investigate right away. One of the things with the camera is you can just move slightly and get stereo pairs, so they're making neat things that you can go take a look at. This website here, MassCamZ, at ASU, Arizona State University, then they have a stereoscopic corner, so they're going to produce these things all the time. So if you have an old set, or even just cross your eyes and try it out, you can get your own stereo pairs and see Mars in 3D. They're doing some pretty neat stuff. Okay, I'm taking up a lot of time here, so I'm going to speed up a bit. This is an orbital view. You may or may not have seen, you may or may not have seen this. This is from the HiRISE instrument from orbit, has been taking images of the Perseverance rover, and this is an image of the rover on the ground as seen from orbit, which is pretty cool, with the blast areas on either side of it there. And the indication is you can put this in a context with other orbital images, looking at what the wind direction is using the dunes and everything around there. They're consistent with these linear features and the rocks around being these ventifacts, or formed by being scooped up by consistently oriented wind coming out of the west over time. So a lot of early science being done with this is pretty neat. This is sort of looking at the rubbly landscape, and a landscape that they don't really want to traverse with the rover, looking some of this anyway, that basically they may not ever make it over to this area here on their way to get into the valley that they want to go up. But again, very compelling landscape. This is one where you can see layering. This is looking basically west or southwest towards the delta, so they want to get over here eventually. But they have to get around the foreground stuff. They don't want to put the rover over the foreground stuff. They're going to kind of have to get around that and then start climbing. So I don't know about in here, or one of these slopes anyway, is what they're going to go up. But you can see there's kind of layering in here, which you kind of expect for a delta. If it's a big fluvial system and has all the sediment coming in, it'd stack up. But the interesting thing is and Jim Bell pointed out, is look at these guys here. They're not flat. They're actually at an angle. And if you zoom in on that, there it is there. There's these things on an angle. They actually are, are they what are called in geology delta foreset beds, or that's the front of the delta that spills out. If you imagine you kept on dumping sediment in of a plane and you had a slope in front, it would want to spill down the slope and make things that actually aren't horizontal. It slopes basinward. So if that's a bed form, it's a really cool thing to see at that scale on Mars, and really would, this is obviously a delta, but it would be nice to see a really big scale sedimentary conformation of that. So that maybe from a distance, that's what this is. Or it could be slumping, like you take a punch, this horizontal layered rock up here, the sediments, and they basically, for whatever reason, slump down the slope and end up down there. That's possible too. You can't tell from a picture alone from that distance. Okay, maybe one of the last things I'll talk about and move on is you may have heard in the early news from this is there were sounds from Mars, and you could hear it on newscasts and the like, and you can download them. And they have 2 microphones on board. And aside from the coolness of hearing sounds from another planet, one of the neat things that you can do with the microphones is when they fire their laser, they know the timing of that, of course. So one of the things that Mastcam Z does is it has built in with it another camera system that this guy Roger Weens is talking about, that has a LIBS, or laser-induced breakdown spectroscopy system. So it fires a laser, makes a little vapor plume by vaporizing target, and then it looks at that and gets the spectra back. But in the action of doing that, the laser fires with a known time, but the microphone that's co-installed on the mast then hears the sound of the laser shot hitting the target, and that sound takes time to go back to the rover. And from that, you can get the speed of sound at the time. You can back out of that what the speed of sound is on Mars, and it's around 240 meters per second. So about 2/3 of what it is at sea level on Earth. But the variations in the speed of sound you can accord with the temperature on the surface locally. You can accord it with other things climatically. So it becomes a different way of getting information about the local atmosphere conditions. So it's pretty neat that they can, build a lot of this in there. So this bottom diagram here is the laser pulses, pop, 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 and they can basically pick up the laser pulses as they're hitting a target. Okay, this is my last slide. Chris mentioned this, and I just wanted to show what it looks like. This is a website where you'd find actually a lot of cool information called unmannedspaceflight.com. And it's outside of any of the official space agency type of websites for information. But on this website, it's been around for about 15 years now, maybe more. But on this website, basically what you find are, and anybody can go there. I'm logged in here as a guest. You can just go there as a guest, or you can register and become a member. It's fine. You go in and you can visit any of these thematic discussion groups. And the discussion groups are consist of amateurs and some professionals who, aside from their day jobs, are actually interested in talking about these things outside of their day jobs, which is really fun. So you get a lot of not unofficial images posted, but there's a lot of people on this news group who get images, say, from various space agencies, and they will work with them and do image processing, much as we've been doing locally in St. John's Center on our own images. They will do the same kinds of things with return spacecraft images in order to pull out more details. So, for instance, there's one of these things is the Tianwen-1 orbiter lander. There's a news group on here, and there's a fellow in there who took some video clips from what was officially released by a Chinese space agency, and he video enhanced them in order to pull out surface features that were seen by the orbiter when it had orbital insertion. So there's a lot of sort of value added and extra in this news group, and people talking about that and talking about what the plans are for the missions. So it's kind of neat. It's a free thing to visit, and you can get lost in here and spend hours and days in here. It's amazing. So anyway, I think that's it for me. I'm going to stop sharing at the moment.
Yep.
There it is.
Phil?
Stop share.
Phil?
And probably open this up for discussions. And Chris, I don't know if you found a movie or not. I never did get a hold of one easily.
I did. It's queued up.
Good. Okay, why don't we do that? And then if anybody wants to talk or have any questions or anything, yeah, we can just chat about it. Lots of neat stuff going on.
I'll just play this.
Oh yeah, that's a good one. Yeah.
Straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
You see the heat shield drifting away.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface.
So you notice we're kind of swinging back and forth because it's still under the parachute, but shortly the image will stabilize when it goes under its own power for the descent station. The rockets take over. Suddenly the image
The timing of the landing.
stabilizes.
Current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. PBA nominal.
We have timing of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
Here on safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. The sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Okay.
That was cool.
Yeah. Almost like being there.
Yeah.
If you have any questions, you can also ask. Easy way to open up your mic is just to press on the space bar. While you got your space bar down, you can ask a question.
Oh, that's true. There was a question here, I think, from John, asking about the small helicopter. I didn't talk about that. I don't know, Chris, if you know much about the helicopter. I know a little bit about it.
A little bit. It's called Ingenuity.
Yeah.
They actually flew it in vacuum chambers on Earth because, of course, the surface pressure on Mars is, what is it? It's a reasonable vacuum compared to the terrestrial sea level pressure. And it works. So it's a very, very light and wispy vehicle with twin rotors. And I think they're going to deploy it, I think it was about 40 sols after landing, so not for a while yet. And given that they have longer to drive and they're still figuring out a way of getting started with the mission because they're further out than they thought. I'm not entirely sure, and I haven't read anything recently, but that's to come.
Yeah, the discussion in the LPSC yesterday was the general plan is they're going to go ahead with their normal planning for that, which is
Okay.
the helicopter operations are one of the very high priority things to do early on, really before they get rolling with a lot of the science. They're still doing mostly engineering related things. And the getting the helicopter working is important because they're going to use that as a scouting platform. So they've already now, just in the last few days, they have selected, they're looking around some of those images that I showed from talks at the LPSC. They're looking at surrounding areas where the rover might go and park in relatively boulder-free ground. They're looking for a good, nice ground in order to do the helicopter operations. So they'll park the rover somewhere where there's no obstacles around, and then they can launch Ingenuity and test it out. And ultimately, I think the intent is that they're going to be able to use it out for some small distance to be able to scout out areas around the rover. And part of that is to decide on best options for where does the rover go next. But also it's just, it extends the eyes of the rover. You know, you can see things that you're never going to get to with the rover because the rover can't go everywhere. So it's pretty, but I think the intent is before they really start rolling and trying to cover distance, they're going to test out the helicopter within the next month and a half or so.
Doug was asking about how far it was going to travel, and I guessed from your map and the scale bar that it was about 100 kilometers. Is that?
Yeah, the initial mission, I don't know the numbers off the top of my head, but the initial mission is something on the order of several tens of kilometers over a Martian year. So, you know, 660, 680 souls. And then the extended mission is a lot farther than that. The rover, like Curiosity is, this rover is powered with nuclear power, with RTG. So it's able to keep working as long as it's mechanically able to move, and as long as it's able to communicate. It can continue to operate, you know, conceivably for decades. You know, it could be. So, you know, they have an extended mission in mind. If once they get the first mission over with within the one Martian year, they'll be wherever they are and continue on from there. And it could be, 100 kilometers or more.
Do you remember off the top of your head, Phil, how far Curiosity has driven?
Ooh, I don't. I think it's tens, many tens of kilometers.
20 something, I think.
Yeah. They've done a lot of investigating things along the way. They had a little back step at the start in order to go back and check something of interest, which turned out to be very interesting. They found a new composition of rock on the surface of Mars, and then head towards the central peak for Gale Crater, which is Mount Sharp, which they're now in the process of going up. But yeah. So they haven't attempted. I think with that mission, the goal isn't to drive a long distance. The goal is to visit a lot of very closely spaced, interesting things along the way.
Bernard Day asks how long the helicopter is supposed to keep operating. Anyone's guess, I think. They'd be happy if they could continue to use it, but at some point, I mean, it requires power, and I don't know if there are any provisions for recharging it. I don't think so.
I don't know. I imagine it would recharge from the rover. It'd be surprising if it wasn't, but I just have not done any homework on that. I just don't know. Maybe somebody knows.
Yolanda asks, can Perseverance analyze any of its own samples?
It's a laboratory. So I did not talk very much. I mean, I could have given more on this. It has a lot of onboard instruments, the same as Curiosity does. It has a similar suite of perhaps even more capable instruments for doing spectroscopy, so looking at different wavelengths of light. It has an infrared spectrometer. I think that's the first one that's on Mars. And what it's able to do is a lot of analyses, obviously of visual images, but also the one instrument I mentioned was a laser-induced breakdown spectroscopy, where it fires a laser and vaporizes some rock. And you can then, looking at the light that's emitted from that vapor cloud, it looks at the wavelengths of the light and can pull out what the elements are. So you basically get a taste of what the rocks are in the area that are within range of the laser around the rover. So you can shoot at things and go zap and figure out, oh, okay, that one's more of a basalt. Oh, that one might be a carbonate. rock, you know, so you can figure out, you know, how much calcium is present, how much magnesium is present, so on. You can figure that out. It has several different instruments that use neutrons. One of them uses a kind of neutron bombardment, I guess, is Pixel. Robbie's sitting here with me. She maybe knows better. And I don't think this one does not have X-ray diffraction on it. The Curiosity rover does have a diffractometer on it, but anyway,
But the UV ones for looking for organics.
Yeah, so there's a UV instrument, Robbie's informing me in my ear, looking for organics. So they're particularly interested in organic molecules. Not necessarily, organics don't mean it's automatically life. Organic means that it's an organic type of molecule that, you know, would be available for life to use. But there are inorganic ways of forming organic molecules, if that makes any sense. But anyway, this is a rolling laboratory, as well as a sample collecting rover. So even if it never succeeds in collecting samples that are ever returned to Earth, it is as capable, or perhaps more capable, than the existing Curiosity rover on Mars. So it's a full package mission already.
Mark Pippi points out that recent Curiosity images are worth Googling. They're quite interesting.
Oh, cool.
Yeah. Anyone else?
Doug's writing.
JPL site indicates the helicopter has 6 lithium-ion batteries that take their initial charge from the rover and then recharge from the helicopter's solar panels upon deployment. Thank you, Doug.
Cool.
Answer.
Quick question. You kind of touched on it just now, so apologies if this is extra repetition, but a question I've often been asked before too, when I just talk to friends and stuff, but I don't have an answer to, is what really are the main differences between the Perseverance rover and the Curiosity rover? Size? Okay, I figured that was one of them, besides like instruments and some of the mission.
Yeah, I'm not sure that the size is really hugely different, but yeah, the Perseverance rover is meant to switch up some of the instruments so that they're able to do more on-site analysis of samples while being able to cover more distance. So the one way to think about this is the Curiosity rover is really meant to do everything on the surface of Mars. And so it even has a X-ray diffractometer that's inside the rover, and you have to collect a sample and crush it up and kind of ingest it into the rover in order to do that analysis. And this rover, Perseverance, doesn't do that. It has instruments that are meant to assess as much as possible the surroundings. Curiosity does this too, but the idea is to do the best selection of samples. What do we want to take from the surface of Mars and store and potentially return to the Earth? So it has that kind of different role. So the suite of instruments is somewhat different to be able to do that. But the two rovers have highly overlapping purposes in that both of them are investigating areas on the surface of Mars where it's thought that there was a lot of water rock interaction, and therefore the possibility for life to have been present at some point. So they both have that sort of in their background as their guiding goal.
Yeah, I think Perseverance has a bit more of an emphasis on the organic side of things, the possibilities of organics. Yeah.
Yeah.
So it's kind of almost like a sister to Curiosity, not necessarily an upgrade or 2.0. That's really cool. And I also wanted to say the getting to see the map and then the video of the landing of Curiosity was really cool, because then I could understand, oh wow, okay, that's where the rough terrain is. So I don't know which one of you had presented it, but that was really cool to include. So.
The questions are over. We can move on to the next speaker. Any questions? I scared everybody off now, have I?
No, but we have several other things to go, right? So.
Yeah.
Okay, well, let's move on. Ready?
If you want to put in chat, that's great too. But yeah, we should probably move on.
We've got a clap here.
No, it's just applause, I think.
Oh, okay.
Yeah, they're cheering everybody on, like clapping for you.
Yeah.
Zoom keeps changing. Go on, Randy. Let's move on. These people are just driving me crazy.
Well, we're just
I'm
having.
loving it.
Okay, next we have Shaziana, who was just asking a question. So the floor is yours.
Awesome. I will share my screen. I have a very quick presentation to make sure I don't forget anything.
Cool.
And I'm talking about outreach. So yeah, I have kind of two projects on the go right now. One is my involvement in Yuri's Night. Another one is called Canada Moon, and it'll kind of come in the later slides. So I'll start off with Yuri's Night. It's a global celebration for the first human to have gone to space, which was Yuri Gagarin in 1961 on April 12th. So this year is the 20th anniversary of Yuri's Night, the 60th anniversary of Yuri's flight, and the 40th, I think, anniversary of the shuttle flight. So Yuri's Night committee is trying to make this a big extra global celebration this year and putting a big push out to global involvement. So I'm kind of helping out on the Canada spectrum, trying to get us involved as much as we can. Canada hasn't really gotten involved themselves as much. So just like a quick overview of Yuri's Night, and they have a whole bunch of information on their website as well. We want to celebrate human achievement in space. There's different ways to be able to get involved in Yuri's Night this year. So they will be doing a live stream. It'll be on YouTube, which you can access on their website, or you can probably just Google it. It's pretty easy to find. Myself and my teammates on my Canada Moon project are thinking of potentially doing a watch party. This is something that anyone can do. So RACNL could also do this and host a live stream so you can party together. There are some ways to be able to do that. So there's like an infographic available online too that looks like this. I can walk you through the different steps to do it. And like I said, Canada Moon might be hosting one as well, so you can always join ours. There's a potential possibility for Canada Moon to interact with you as well on the backstage pass. This is something, it's $15, so Yuri's Night often does have tickets, and this is one of those parts that is ticketed. And it's called the Filmocracy part, where they'll have exhibitions and ways to be able to meet people. So for example, it'll look like something like this, which has been often used in conferences now. So you can go around and network and get to talk to people all over, whoever has decided to be in here. So potentially all over the world. So that's really neat. And like I said, there'd be potential to maybe meet Canada Moon team members. There might be some speakers there. I know they've got a really cool list of speakers, from astronauts to big industry people to musicians. They have a DJ and an after party as well, which I forgot to put into my slides because I did make them a little last minute. With the Filmocracy part, all of the proceeds will also be going to charity for cancer patients for a scholarship to attend space camp. There's also, I think, the VVIP Lounge Pass. It's a lot more expensive because it comes with this extra option. But I did just realize I think this might only be available to US attendees, unfortunately, because they have to mail out the cocktail kit. But there is a portion to the night, I think, where you get to learn how to make a cool, fun, spacey cocktail. So it's basically a big party night to celebrate space. And like I said, there will be tons of different speakers and everything. It'll be on April 10th. It's a Saturday night. And I think it starts at 4 p.m. Pacific, so 7 p.m. Eastern, so 8:30 our time. And it's a 3-hour show. There will probably be some preamble. I think my team will probably host the watch party like an hour beforehand. And there's also an after party later on for any of the paid members. Or we might host an after party as well. You could always host your own after party. There's also the option to restream, which some other people might be doing as well as restreaming the live stream, which I didn't include in here either. So if you know any other influencers, they might already be doing this or want to do that. And that's also something, if RASC has social media networks, you can also do that too, to be able to involve yourselves in Yuri's Night. Or you can just have a nice quiet night at home or party at home and just watch the live stream. That's always a good option. So yeah, this is just kind of pass on the word, let you know what's happening on April 10th. And as I mentioned, Canada Moon is my project. It's a project I'm leading that will hopefully be involved somehow as well. We're coming up with an idea for bringing space and art together in a new way to inspire and raise the excitement in Canada for the upcoming new missions and the new space era. So we want to make this kind of digital scrapbook where people can give us different types of artwork, mostly visual or short written prose. And we hope to be able to print it at the end, send it out to different museums and companies for outreach purposes, and just to get people interested in space in another way. So for us, we're kind of really just in the preliminary stages, getting our fingers out there, looking for support and volunteers or interest, sponsors, feedback, anything. So if anyone has any ideas or knows any people who might be interested in joining us, we're always looking for anything and anybody. Our timeline is to be determined, but we're thinking about bringing in submissions or opening up for submissions by July 1st. And so we're kind of also using Yuri's Night as our soft launch date. So you're getting the preview of what we might be doing right now. We have social media available to keep up to date and to look for updates. Similarly, Yuri's Night does as well. And so if you get to join us on Yuri's Night, you'll get to see even more information about our Canada New project. And yeah, that's kind of the short, sweet talk of the outreach that I have going. So if anybody would like to ask any questions or give me ideas, feel free.
Thanks for that. Looks very interesting.
Awesome.
Yeah, good luck.
Thank you. So yeah, if there's any interest or anything, I can try to reach out to Randy further when I have more information on both topics. Things are still evolving for Yuri's Night as well, which is pretty neat. They do have, actually I could show you guys their websites too. I did plan to do that, I realized. So for example, this is our Canada Moon website. Still preliminary, as I mentioned, but basically shows everything. It's just canadamoon.com, nice and easy. And these are my two collaborators as well, both with their own outreach startup companies. One is in Toronto, that's Jay with Starscape Creative, and one is in Montreal, that's Trevor with Alta Astro. I met them through different ways. Trevor does urban astronomy and practical space education for like city-based stargazing, which is really neat. And so I met him during my studies in Montreal. And Jay I met during my studies at ISU, the International Space University, and his company's Starscape Creative based in Toronto. And he's also bringing the kind of space and art pop culture together. So that's how our team kind of formed. For Yuri's Night, this is what their website looks like. And they are also recommending rather that, and yes, they did have Buzz Aldrin come out to one of their events in the States. So it is based in the States. They've had people come out like Bill Nye, a number of astronauts, Yi, who is the first and only South Korean astronaut. And they even have different resources available online to learn how to create your own parties or join the party. You can register your event. So if you want to do a live stream or a watch party, and then they can get an idea of everybody who's coming in to watch. And there's all the different links and different people who are coming in to speak this year. This is Loretta Whitesides, is actually the founder of Yuri's Night, so she's the first time working there. Okay, I think that's all.
I actually follow Tim Dodd's channel quite a bit.
Oh yeah.
Yeah, Elon Musk's people are trying to launch Starship,
Right.
and land it without exploding it.
Yes,
so.
yes. Yeah, it's
That's
pretty
good.
neat.
Yeah.
Did you see the recent SN, I think it was 10?
Yeah, SN10.
10 landed, and Leaning Tower of Pisa, I think it crushed something underneath and it eventually exploded. 11 was supposed to have a static fire yesterday and the day before, and they aborted like this. It's this week. Friday, I think they're going to try and launch SN11 now. So
Oh, wow.
yeah, so
Very neat.
Hey, Shaziana, what kind of art are you looking for?
That's a great question. So it can be pretty much anything that you can take a picture of or write about. So because we wanted to be a scrapbook and to be something for now digital because of the pandemic, but then we want to be able to print it as well and either put it into libraries and museums. We want it to be very visual and easy to kind of relate to. But that could be, it doesn't have to be a painting or a drawing, which it can be, but it could also be a picture of a sculpture. It could be a picture of a Lego thing that you made. It could be a picture of anything that you created that's spacey that you can send us. If you want to write something, you can write something. We don't want like a page written. We only kind of like a snippet, so like a haiku or a short poem or maybe a chorus to a song, something like that. So those are the types of pieces we're looking for. But if there's anything in that kind of realm, but also still outside of the box, we're definitely going to want that too. That reminds me as well, I think Yuri's Night is still doing another promotion thing, which is if you're creating a piece of art, you can send them a time lapse. So if anyone's interested in this, you can let me know and I can get you more information. So you can send them a time lapse of you creating your material or your artwork. And if you make it Canada Moon related, you can send us your artwork and send them your material.
That's neat.
yeah.
To answer your question, Mark, when would you need the art picture? So right now we're not open for submissions, so you keep your eyes peeled for further updates. I can keep in contact with the team and with our group here and let you know when that happens. We're hoping for July 1st to open up for submissions, but we've got to work out some details. We do want it to be a contest as well, which I neglected to say. I forgot that, but we're hoping to have things like a telescope and puzzles and whatnot to hand out to people. So we kind of got to get those first.
You want to type your web pages on the chat
Totally.
so that people can click it and keep it? That would be great.
Yes, let me do that.
I can include them in the info on the YouTube for this video as well.
Awesome.
Yeah. Canada Moon.
Okay.
So if you go to CanadaMoon.com, all of our social media and email is all on there. You just have to scroll to the bottom.
Thank you.
Thanks.
Next is observation and photos, if any.
Oh, yeah. Geez, right. Okay, I'll share my screen. All right. I think Mike is up first. Mike.
Okay.
And do your, okay.
So it's probably a series of 4 open clusters from about a week ago. And they're up around, well, they're M35 to M38. And so M35 is near Gemini. So sort of the southwest sky, fairly high. And then M37, so this one is M35, that's the one that's near Gemini, and then the other 3 are around Auriga. So this is M36, which is just, if you think, I think of Auriga as sort of a pentagon, and this one's just inside the side that's facing Gemini, and to me it looks a bit like a starfish, but this is the one I think that they call pinwheel. And then the next one, 37, I guess, is a little bit south of that. So it's just outside of the Pentagon. These are all about 4,000 light years away. That with M35, there's actually another cluster that's about 11,000 away. And then the last one is M38. And this is the one that is actually called the starfish cluster, but it doesn't look as much like a starfish to me as the other one did. But it's also called the pie cluster. And there's another cluster which I don't have the name for right now. It's in another NGC cluster down there. So those are sort of nice. They're all in the same part of the sky, which is about the only part I can see at this time of year. And I don't know if you had the double cluster there as well or not.
No,
Nope.
no. Didn't show up. Okay, Chris.
Oh, yeah, okay. Yes, we rather politically correctly now do not call this what we used to call it. We now call it the Clown Face Nebula or the Lion Nebula. I think it's a planetary nebula. This is just a quick shot with a camera I had on the telescope for actually recording planets when we were doing Mars, but earlier in the evening I was trying to get Sirius B. So this is a whole lot of short exposures. It was unusually sharp that evening, so the sky was quite steady. And this is looking way up, and I am ashamed to say that because I've come prepared, I forget exactly where this is.
At Gemini.
Yeah, it's in Gemini. It's rather high. It's not too high because I can't point my telescope at zenith. The dome gets in the way. Yeah, so planetary nebula, white dwarf in the middle, ionizing the gas around it. The old name involves a parka with a hood. I still see that, unfortunately, but. And yeah, on the same evening, a parting shot of the good old Orion Nebula. This time the trapezium. The idea here was to try and resolve the 10 accepted members of the trapezium itself. And so Theta Orionis 1c is the most massive, and it's the O star. It's the brightest white dot, largest white dot there. And it emits ultraviolet light that powers the entire nebula. That's what ionizes everything, because its surface temperature is so high. But there are 10 other stars, and is this the one where I got all 10 of them, or is this? Yeah, I think I showed that one too, but
1, 2.
A little later, there's another one I took recently. I don't even know if I published, if I sent it around. I got all 10. Anyway, yeah, it was a clear night. Always nice to look at the Orion Nebula. Oh, yes, okay. I was hoping you put this one in. So this was an attempt to see Sirius B, the white dwarf companion nicknamed the Pup, to Sirius A. Right about now, you can see in the diagram on the right-hand side, right about now is a good time to look. Because where the separation is rather large. It's about 11 arc seconds now. And you'd say that's lots of sky to put between A and B. Well, yeah, but when A is, I don't know, 1,000,000 odd times brighter than B, you have to have clean optics. And our trees in our backyard have grown over the years. And I can only look at this without looking through twigs for a short window in the evening. And I planned it and caught it in the window. So I tried it a few days earlier, and there are twigs in the way, and the twigs diffracted light all over creation, and there's no way you could see anything clearly. Here, B pops out. There's also another couple of background stars you can see on the left-hand side. And just to convince yourself that that image of B is real, it has the same somewhat elongated shape as the other stars. So I was happy with that.
Actually, it's quite good, actually. I love how it pops out so easily. This is very popular, actually. I've been to a few other centers, and a lot of their observers are asking to see if they can see this. So you've caused a trend.
Oh, wow. I guess I'm just riding the same wave.
Yeah, I noticed Kingston and Winnipeg, and I think out in BC, one of the ones out in BC were promoting it. See if you could see it.
Any successes?
At that point, they were just suggesting to look. No one had seen it yet. So you're the only one that I can confirm has actually put something up so far this year.
I have to check the others.
Yeah. Probably later on, now that most people know about it.
Yeah.
Good work, Chris.
Thank you.
Really impressive. And there's another one for you, Chris.
Oh yeah, just party shot. This is just the last weekend. One of our members returned the center's portable solar telescope, and another one was going to pick it up. And I had it for a couple of hours, and it was a beautiful sunny Saturday morning. So I stuck it on a tracking platform, a tripod with a tracking platform head on it, and stuck an eyepiece camera in, and took a video of what, 2 millisecond, 4 millisecond exposures, I think. Very, very minimum gain. You know, even through a H-alpha telescope, red sensitive CMOS cameras, you really have to turn everything off before you saturate it. Got some solar prominences on the edge, and I was happy to report that it's all real. There's something called the GONG network. It's a global H-alpha monitoring network. Solar telescopes set up in many places in the world, and the detail is real. The photosphere here shows a little bit more of the granulation than the really, really high professional H-alpha, narrow H-alpha filters do. And so it's a kind of a mixed bag, but you can see you're sort of near it. Go to the right and up a little bit. There's a sort of a wrinkle. Well, that to the left, left, that's it. There's sort of a little pucker wrinkle there. I think that's a very, very faint sunspot if you were to see that in the visible. And anyway, I was pleased with that too. The prominences on the lower left look like electric discharges. It's rather funny.
They're still there today.
Oh, okay. Very good.
And a lot of activity up here, I noticed on mine. And a nice seagull went across mine in red. Okay,
Yeah, so,
nice day. Is Jim there?
I am here. Can you hear me?
You want to talk about your supernova?
Yeah, I can't even remember the day we shot these, Gary. I think that was probably about 3-4 weeks ago now. I think it was before I went offshore last time. But yeah, we were having hangouts, and we just picked a couple of different targets and stuff. And this is a supernova 2021J in NGC 4414. So I don't know if you want to point it out there, Gary. It's not that bright star.
It's the one in between.
That's actually a foreground star. It's actually in between that star and the core of the galaxy.
And I can't zoom any further. What about? It's in between, right there.
Yeah, I think I did send a better image later in the talk list, but you probably don't have that one there, do you?
No, I don't. That's what happens when people. That's what happens when people don't send me their pictures, and I got to go looking through the newsletters.
Sorry, I was a little preoccupied the last couple of days.
Well, I forgive you for that. I know what you were doing. Okay, I think that's the only one I got of you, and I'm going to end this off with Susan's. Sue, are you there?
Yes, I'm here.
You want to talk about this beautiful shot that you got when you're out for a walk?
Yeah, I was snowshoeing, and quite a serious snow squall, very low visibility. But anyway, all of a sudden it kind of cleared a bit, but it was still snowing, and the sun peeked through, and I just thought it was a really neat image. So by the time I actually got my cell phone out, I'd lost the kind of halo around the sun, but even so, it was really, really quite haunting, the actual image.
It's very good, actually. I like it. I also like the close-up of the finger in the corner.
That's right. Yes, indeed. The specs actually is not my dirty cell phone. That's actually the snow, because it was still snowing at the time, quite heavily, actually. Yeah.
Yeah. Well, it certainly talks to us about how wonderful our observing weather has been in the past couple of months.
Yeah.
Anyway.
No, it was really neat to see.
Thanks very much, everybody, for taking part in our What's Up. And I'll stop sharing. And I'll send it back to Randy. What do you on our list?
Nikolai with this guy this month is next.
Okay, Nikolai.
All right, can you hear me?
Yes.
All right, hello everyone. I'm going to share my screen. Okay. Can you see this?
Yes.
Okay. All right, so I'm going to be talking about what you can see from here in the sky over the next month. Starting off with sunset and sunrise times, we are pretty much equal for day length and night length this time of year. Moving on to planets. These are the rise and set time for each planet and when it crosses the meridian. Then we have the sun. This picture was taken yesterday, and you can't see it really well, but there's actually a sunspot group beginning to emerge here as we discussed in the upper left. So that will be rotating into view, possibly providing some material to observe if you have, of course, a proper filter for that. Never look at the sun without proper filters. Now on to planets. Evening planets, we only have Mars right now. It does shine brightly, somewhat low in the evening sky after sunset. It's too small though for observations. It's only 6 arc seconds, so you won't see a whole lot. I guess Uranus is also visible, but it's really low. It would be quite the challenge to see it. Morning planets, we have Mercury. So Mercury reached greatest elongation on the 6th. So it's currently a morning planet, but it is sinking lower and lower after that event. And it will be hidden in the glow of the sun before re-emerging again in mid to late April. It's not a very favorable apparition. We do have Jupiter and Saturn very early in the morning, just rising about 1 to 2 hours, each before the sun, just visible very low in the sky. So in the coming months, they will be much better placed. Planets that are not visible are Venus, Uranus, and Neptune. And here in yellow, I am issuing an observing challenge, an idea that Mike proposed specifically for visual observers, because we felt that the people who take pictures are naturally overrepresented. So this is only for visual observers. If you do want to take a picture, you're welcome to do that and you can share it. However, the observing challenge for visual observers is to try and spot Venus as it reemerges as the evening star by mid-April, and specifically before our next meeting, which is on April 21st. So try to see Venus before our next meeting, April 21st, and report to us whether you have been successful. It should become visible, definitely visible by the 18th, but with some luck, especially weather luck, you may spot it even, in the week prior to that. Binoculars are recommended, and you need kind of an unobstructed west-northwest, but mostly west horizon, and look very low in the cloudless sky. The task, the challenge is who can spot it the earliest. So make sure you take note of the date when you spot it. And I do have Stellarium here. I'm going to search for Venus just to show you what we're talking about in terms of challenge. And I'm going to change the date to, can you see this? Yeah, okay. So I'm going to change it to April So a month from today, April the 17th. So here it is, basically right here. It's kind of hard to see, but you probably go to the 18th or 19th. You will just kind of see behind this tree here.
Turn off your scenery there, Nikolai.
Oh yes, how do you do that again?
On the bottom left. Drag your cursor down to the bottom, get the bottom control panel.
Okay.
Who put that tree there anyway?
Yeah. Round. Oh,
Great.
well, that's not it.
You
Yeah,
may have to cancel out your date there.
you can choose different grounds, but anyway, that takes time.
Well,
Just cancel out your date.
I was able to see it even with the tree there. Anyway, my point is it's really close to the sun. It's literally setting 20 minutes after the sun right here, just kind of to the upper left of the sun. So look, be careful if you try to see it during the day, which you can do. Just be very careful with the sun if you do that. But I would recommend just waiting for the sun to set mid-April and then scanning the horizon with binoculars due west. So please report next time if you have been successful. And we'll try to issue those, every month, something fun to do and to try to observe visually. Moving on to comets. These are the top brightest comets right now. This one is the brightest, peaking basically just now at magnitude 6.3. Has anybody seen pictures of that? I haven't. But yeah, you would have heard, if it was more exciting than that. List of asteroids, supernovae. I saw that the latest was 12, magnitude 12. I don't know if the one that was featured is still visible. And these are the meteor showers. Deep sky objects, of course, we have the Beehive cluster in Cancer, and it's the Leo triplets, the triplet season. The Virgo and the Leo galaxies are all very well placed this time of year, March and April. So that would be a good thing to look at. List of ISS passes, quite a few until about April 4th. And this is the observing calendar, which there's no observing sessions. Yeah, and next meeting is April 21st. That should be it. Are there any questions?
Oh, thanks, Nikolai.
All right, no problem. Let me stop sharing.
Good job, Nikolai. I like the
Thanks.
Venus channel. Okay. All righty, I think that's everything on our thing as we're getting close to the end here now.
Yep, that's all the schedule had.
Okay, anybody have anything to add before we sign off? I want to thank very much Phil and Chris for giving a great talk. I really appreciated it. I learned a lot more than I thought I was going to. It was nice to see some in-depth exploring in the geology side, because that's sort of a little passion with me these days. I just know, by the way, Phil, I just noticed that even 50 years later, the Apollo 14, a geologist down in Australia was looking at one of the rocks brought back, which was granite from actually the Earth when they did the research. Did you know? Have you seen that report?
No, I haven't. No, that's neat. But
Yeah,
there is supposed to it's very likely there would be terrestrial rocks end up on the moon and just, you know, blasted off from the Earth and end up preserved on the lunar surface. So it's possible to do that. But no, I hadn't seen that.
Yeah, they had gone right down to the zircons,
Zircons, yeah.
zircons, and they're the exact same makeup of the Earth as opposed to the ones they found on the other moon rocks.
Oh, okay, that's cool.
And it was picked up in the Apollo 14 one, and noticed as a strange rock that looked like a granite.
Yeah,
I thought, you know, it's like, here they're still finding stuff 50 years later.
Yeah. Well, I'll take a look through the LPSC meeting. There may be something on that there. That'd be cool. One of the things you're reminding me today, this wasn't the topic of tonight's Mars focus kind of thing, but today there was a session focusing on the moon and new exploration of the moon. And there was a speaker from the Chinese Space Agency talking about the Chang'e 4 and 5, the rovers and the sample return that just came back. And that was really cool to see some of the early results from that. And then there's, speaking of the Apollo samples, Chip Shearer, one of the people who was involved in the original Apollo program back in the late 60s, early 70s. He's now leading a consortium of scientists basically treating the existing 50-year-old stored Apollo samples that have never been opened. There's a whole set of them that have been set aside all this time. And they're now taking a couple of the sample tubes that have never been opened from the time when they were sealed on the moon's surface. And they're now treating that like a sample return mission, but using instruments and available science now as opposed to what was done in the 70s. So pretty neat stuff being done now. And they're figuring out, okay, well, we figured out in the 70s how to store these things. The astronauts on the moon, you know, put these core samplers, like soil core samplers, down to the ground with vacuum cutoff and took samples then. But at that time, they weren't quite sure back on Earth how to open those safely, so they left them sealed. And so now they're figuring out how to open them safely, and they're presumably totally pristine samples. They did CT imaging, so you can see there's a bunch of sample inside, and, you know, rock fragments and the like. But, you know, it's new. It's a new Apollo sample, and new results will come out now, 50 years later. So it's pretty cool.
Very cool.
Very cool. Anyway, thanks very much for everybody coming. Any questions before we sign off? I want to remind everybody, April the 10th. Usually at term I have a short 10-minute program on his flight with movies and stuff like that, which I usually as part of it. And of course, the planetarium has been closed down for the past year and a half, so it won't be shown this year. But it's been, it's kind of old. It's been around. I've had it for about 5 years now. So type of thing. But everybody gets quite surprised to actually see him in his flight and parading and stuff like that.
That'd be neat.
Good luck.
That's really cool.
Yeah, that'd be neat to see, Gary.
Yeah,
Well,
you could totally.
It's done really good. Really weird song, Russian song tune to it. But it's kind of good. It's actually nice. And there's not only black and white, but color, actually.
Yeah.
Anyway, good night, everybody. Happy observing, clear skies.
Yep.
And take care.
Bye.
See ya.
Take care, everyone.
Good night, all.
Yeah.
Have a good time on April the 10th. And look for Venus.
Absolutely.
See, it'll be my time.